So, the point is made that these extensive alluvial deposits, not only in the delta region, but also along the continental shelves, massively greater scale, required a tremendous river to erode and transport and finally deposit them, seems as obvious as anything could well be. By all odds, the most reasonable explanation of these things is that one or more great streams initiated in the post-deluge uplifts, and perhaps later augmented by glacial melting, laid down these alluvial fills after carving the great valley, and then, in response to intermittent uplift toward the north, left the present raised terraces. Either huge, catastrophic initial flood examples, or later on, vastly more rapid catastrophic filling of these huge amounts of sedimentation and uplift. The terraces all tend to converge as they approach the Gulf, the oldest terrace being the highest and therefore reflecting the greatest period of greatest discharge. Furthermore, the terraces are as different to explain in terms of supposed former higher sea levels, which evolutionists also proposed. Well, how did they get to be higher? Catastrophism. Most of the evidence in favor of higher sea levels is supposedly provided by terrace and shoreline features which now occupy elevated positions. But the alternative possibility exists that continental margins and interiors have actually risen positively rather than the sea level. If there were freshly created shoreline features widely distributed along the maritime coasts at some comparatively uniform level, such as 200 feet, the argument that today's sea levels represents a lowering by that amount would be strong. On the other hand, if shoreline features stand at a variety of elevations, which is the case, the suggestion is fairly conclusive that elevation is raised from the differential elevation of rising land masses, and the latter appears to be the case. Something on the wide scale of a worldwide flood could easily handle that. Furthermore, if there were more than one glacial period, which evidence does not support, then the hypothesis that higher sea levels produced by a supposed interglacial period, when there was a melting down of the glaciers between glacial periods, would still not be supported by the evidence. Richard J. Russell states further that interglacial seas at times may have exceeded today's stands is possible if there were more than one glacial period, but not by the differences of level suggested by positions of higher terraces, for many of these surfaces are located above the level which would be established if all continental ice should melt. Russell. Thus, are you with me on this? The inconsistencies, wide massive scale, then can provide for the variations. Thus, the height of the raised river terraces can only be explained in terms of intermittent uplift processes, such as terminated by the deluge period, and the width of the valleys and their great depth of alluvial fill can only be reasonably explained in terms of great swollen rivers plunging rapidly toward the sea. Great worldwide flood. Where does it all drain? Whoosh! Gone. Mississippi River Delta. This evidence from the most thoroughly explored continental shelf on Earth refutes the physiographer's lateral corrasion by hypothesis for the lower Mississippi Valley and an erosional explanation for the shelf. A deeply alluviated major valley leads to a deeply blanketed shelf. The flatness is depositional rather than erosional in both cases. Richard J. Russell. Further proof that the rivers formerly carried much larger quantities of water is found in the great size of their original channels as cut out of the bedrock. As has already been stated, the bed widths of the filled channels are some 10 times those of the present channels in the same localities. Worldwide flood. The whole of the present annual precipitation, with no loss to percolation or evaporation, could similarly have been run off in no more than 5 days. It is therefore necessary to postulate a form of precipitation greater, and probably considerably greater, than that which is now recorded. Worldwide flood. Where is the elephant in the room? Right there in the middle of the room. G.H. Jury. Theory, model tests, and field observations all demonstrate that there is a definite limit to the width of a stream's meander belt, and this is always much less than the width of the alluvial plain on which it flows. Something bigger came before it. What do you think? The Basic Aspects of Stream Meanders by Gerard Mathis. Mention should also be made of the old marine shorelines that are now found around all the world's seacoasts. As we have noted, these raised beaches are found so universally that they have been considered the chief evidence of eustatic worldwide variations in sea level. In various parts of the world, elevated strand lines and terraces exist which are believed to have had a marine origin. If these were local phenomena, their positions above sea level could be explained as the result of local diastrophism, but they are so worldwide in extent that they seem to be related to eustatic rise in sea level rather than to local uplift. Glacial geologists have long been intrigued with the idea of correlating these old beaches with the supposed interglacial warm periods when the ice sheets had melted and filled the oceans to a higher level. But in spite of intense study directed to this end, such correlation has proved quite elusive. It's just striving to find something that doesn't lead back to a catastrophic worldwide flood. Finally, if we evolutionists can follow continuously a system of terraces all along a river valley and see them united on the one hand with moraines, glacial deposits, and on the other with ancient shores, the whole problem of correlation is solved. Unfortunately, and contrary to expectation, it is extremely difficult to follow fluviatile river-formed terraces continuously from the region of moraines, glacial deposits, as far as former marine shores. Too many unique different events occurred, which is only created by worldwide flood, where all these things cannot be explained one small thing at a time. One is warranted, therefore, in suspecting that the multiglacial hypothesis may perhaps be wrong after all. Although the old marine shorelines are found around all the mountains and the continents, they could reflect universal continental uplift processes just as well as higher sea levels. In fact, their irregularity, their varying number from place to place, and the great revelation of some of them strongly favor the former explanation, as Russell pointed out. Evidence of former lower sea levels. Yeah. Shallow seas, lots more water. Continental shelves. There does appear to be much evidence of former lower sea level. I should say plural, these sea levels. What do you think? The topography of the continental shelves, the irregularity of coastlines and great submarine canyons, the seamounts, similarities between faunas of now separated areas, and many other factors seem to indicate that they were formed at least in part at a time when the sea level was relatively lower by several hundred feet than it is at present. The continental shelves themselves are evidence of a former lower sea level, since their edges mark the true boundaries between ocean basins and continental blocks. The continental shelf extends out as much as 750 miles, with an average width of about 42 miles. All right. And you just air all that water up, and where was it? Up in the stratosphere. And descends gradually to a maximum depth of from about 300 feet to about 1,500 feet, with a mean depth of about 430 feet. A lot of water. Between the shelf, the continental slope then descends to the ocean depth. As already noted, most evidence favors the view that the continental blocks were uplifted or the ocean basins subsided, or both, by a great fault along the continental slope. All 7 continents. This, of course, accords quite well with the biblical implications that the uplift of the lands, coincident with the subsidence of the ocean basins, marked the terminus of the universal inundation caused by the Great Flood. This uplift, or fault slippage, along the edge of the granite blocks of the continents was intermittent, largely being completed during the flood year by evidently continuing on a lesser scale for many centuries to come. The present continental shelf could well define the edge of the oceans as they developed during the glacial period. The best calculations for the depth of ocean lowering during the so-called Pleistocene, due to the water locked in continental ice sheets, seem to be of the same order of magnitude as the average depth of about 430 feet of the edge of the shelf. J.K. Charlesworth. With the melting of the ice sheets, the oceans rose to their present level, and with minor fluctuations have remained at that level since. The ocean basins can thus be characterized as overfill or overfull. Water not only fills the ocean basins proper, but extends out over the low margins of the continents. We have Trumbull, Lyman, Pepper, and Thompson. This guy does a lot of research, and so he doesn't pour all his eggs in one basket. There is even some evidence of a past lowering of sea level to much greater depths than that of the continental shelf. These evidences include the great depth of some of the submarine canyons and some of the flat-top seamounts, for both of which there is strong evidence for formation above the sea level, and the many freshwater and shallow water deposits found in recent years in deep sea sediments. If convincing evidence should eventually be forthcoming that the sea level actually was several thousand feet lower than at present, as some of these data seem to indicate, then it would appear that the only logical explanation of such lowering would be simply that there was no more water in the ocean at that time. In other words, that must have been the antediluvian sea level. It is obvious that the immense amount of missing water involved in this amount of lowering could not have been frozen in a great ice sheet, as some of them contend, and there seems no other way of explaining it where it could be. Look up. And if the second alternative is chosen, that of a relatively sudden increase of 30% in the volume of the ocean, the compelling question of the source of this water must be faced. And where do you think that came from? And this few geologists can bring themselves to do. But the problem becomes simple if the existence of the antediluvian waters above the firmament precipitated at the time of the deluge is accepted.